Hello viewers, you are welcome to my channel. Briefly, I want to talk about the unusual stability of benzene despite the fact that it has pi electrons or multiple bonds around the ring. Primarily, alkenes have this structure, and in a double bond we have what is called pi electrons. Pi electrons are highly delocalized, that is, they are not stable, they are eager to move out of the molecule. Therefore, in the presence of electron withdrawing groups or species like halogens, this pi electron is eager to jump into a halogen atom, and the compound will transform to a compound that has single bond or a saturated compound. Like in the presence of chlorine, this pi electron is able to jump into chlorine, and we have this. This is called addition reaction. Addition reaction is common to unsaturated compounds like alkenes or alkynes. Now let us look at benzene that also has pi electrons. This is a benzene structure. And of course, benzene has three different double bonds, meaning that the pi electrons are in excess. So in the presence of chlorine, what happens? Nothing will happen. Why? Does it mean that the pi electrons cannot jump into chlorine again? Despite the fact that benzene has pi electrons, it is unusually unstable, meaning that these double bonds are behaving like single bonds, because benzene exhibits what is called resonance. Now look at what happens in benzene that makes the pi electrons inaccessible. This particular pi electron, instead of moving into an electron-loving species, it moves into another region of benzene where there is single bond. And this one will shift to another region where there is single bond. And this one will also shift to form a stabilizing structure, where the double bond is re-established here, this one is re-established here, and this one is re-established here. These two structures are called the canonical structures. Canonical is a term borrowed from canons in a Roman Catholic, where you see monks resembling themselves because they have the same attire. If you look at one, it resembles the other one. So that is where canonical is gotten from. So these two structures are called canonical structures of benzene. This one can also do the same, and return to this. And this one will repeat it, and return to this. And this resonance continues to now form the real structure of benzene, which is called the hybrid structure or Kekule structure, because this is what Professor Kekule saw in his dream and published it as paper, although scientists argued that you cannot use dream in a science community. But finally, experiments revealed that it is true. So this is what Kekule saw, and it is called Kekule structure of benzene or the hybrid structure. This circumference shows continuous resonance of a benzene, and because of that, this is what benzene is in actual sense. So that in the presence of chlorine, chlorine will be looking for a pi electron to attack, but the pi electron is not accessible. It is nowhere to be found. That is why this reaction will not happen. But recall that there are hydrogen atoms here. So what happens is that chlorine will pick hydrogen, and we have chloro-substituted benzene like this, plus hydrogen chloride. This reaction is called substitution reaction because one of the hydrogen atoms is replaced with a chlorine atom. Substitution. So when you are asked why benzene does not undergo addition reaction, this is exactly what should come to your mind. But does it mean that benzene cannot undergo addition reaction? If you use some catalyst, you can lower the activation energy of the reactants and make breaking of the double bonds in benzene possible. If you found this video useful, click on like, comment, share the video, and subscribe to our YouTube channel. Bye.